Hello students, in the last class we have completed the first chapter, that is solid state from your syllabus, and today we'll go with a new chapter, that is solutions. Okay. So already you have some of the basic ideas regarding with the solutions from first PUC, and also even in case of your 10th as well as in 9th also you have studied some of the important concept related to the solution. There was no any kind of much description or much enormous explanation about these concepts, but also you have some kind of ideas regarding with solutions also, right? So generally in this chapter, so you'll get two important problems, so one or two important problems, and 1 marks 2 questions will be asked from this chapter. Most of the times they have repeated the questions, and it is very simple, very interesting and very easy chapter. So let's start with the second chapter, that is solutions, right? So as we already know that the solutions are the mixture of solute and solvent, right? So there are two components, one is solute, another one is solvent, right? So the homogeneous mixture of solute and solvent is generally called as solution, that we already know, right? So the mixture of solute and solvent is generally known as solution, right? And here in a container, if I take a water molecule, right, and if I add 5 grams of sugar or 5 grams of salt or anything which can dissolve in this, right? So that will convert into solution. When solute mix with solvent, generally we'll call it as solute plus solvent will convert into solution, or solute plus solvent will give the solution, right? So if you want to define solute means the any component in a solution which is taken at the very smaller quantity, right? So the component which is taken at the smaller quantity is generally recognized as a solute, and the substance which is taken at the larger quantity or larger excess is generally termed as solvent, right? So which means the solvent has the capacity to dissolve the added solute molecules. Solvent has a capacity to dissolve these added molecules. So therefore solute will be at very less concentration when compared to that of the solvent, right? So therefore solvent has the larger quantity. Whenever solute and solvent mixes, so they will convert into solution. Therefore solution is nothing but it's a mixture of solute plus solvent. So we can define like that. So further, if you go for the types of solutions, what are the different types of solution? Generally the solutions are of two types. One is homogeneous solution and the second one is heterogeneous solution, right? So the first one is homogeneous and second one is heterogeneous, right? So the word itself says homo means the same, hetero means different, right? So homo means the same, hetero means different, right? So therefore the homogeneous solutions are the solutions in which, right, so both the components are in same phase. Here the components are solute and solvent. Whenever the solute and solvent are in same phase or it is in the single phase, these are generally recognized as homogeneous solutions. And the solution in which the two components are in different phase, whenever they are in the different phase, these are generally recognized as the heterogeneous solution, right? So here I have given the representation. Whenever you take water and milk in a same container, so it looks like water will completely mix with milk at certain extent, right? So it will mix with milk, then it is called as homogeneous, because both water and milk are present in the same phase and there is no any line of demarcation. So you cannot separate very easily that water and milk, right? So there is no any kind of separation line that could not be observed in this case. So therefore these kind of solutions are generally called as homogeneous solutions. And in case of heterogeneous solutions, what happens? The solutions in which the solutions are in the different phase. The two components, one is solute, another one is solvent, and both are in different phase and both are separated from a particular line, right? So that is a line of demarcation, right? So there is a line of demarcation which means which will not completely mix. These are immiscible, generally the two immiscible liquids, so which are generally called as heterogeneous. Heterogeneous means the solutions which are in different phase. For example, if you add oil and water, right? So if you take oil and water, generally oil will be present on the surface of water. Oil will not completely mix with water because these both are heterogeneous, which means they are in the different phase, right? The same line of demarcation cannot be observed in case of homogeneous. The main thing is homo means the same. They can mix each other. Hetero means both are different. They will not completely mix, or either they cannot mix each other. So these type of solutions are called as heterogeneous. Therefore, the solutions are further divided into two types. So one is homogeneous, which means the solute and solvent are in the same phase, or two components which are in the same phase. And in case of the solute and solvent are in a different phase, which means if the solutions are not miscible, if they are immiscible, they are generally called as heterogeneous solutions. And generally here in this topic we'll study about the binary solutions, right? So the word itself says binary means 2, right? So whenever it consists of two different types of solutions, these are generally called as binary solution. The overall study is about binary solutions, and these binary solutions are further divided into three types. One is the solid solutions, second one is the liquid solutions, and third one is gaseous solutions, right? So further these are divided into solid solutions, liquid solutions, and gaseous solution, right? So there are three different types of binary solutions. Binary means which are made up of two components, right? So here the binary solutions are further divided into three types. The overall study is about binary solutions. First one is a solid solution, second one is a liquid solution, and third one is gaseous solution. So here in this case, right, so already we know that the solution is made up of two different components. One is a solvent and another one is a solute, right? So that is solute plus a solvent will convert into solution, right? So here in this classification of binary solution, the solvent is kept constant and there is a change in the solute, right? So one time, so we have fixed the solvent, and for that we have added different molecules or different solute components like a solid added to solid added to liquid, solid added to gas, right? So which means the solid is a constant which acts as a solvent, and we will replace solid by liquid by gas which acts as a solute, right? So this is the one important classification of binary solution, that is solid solution, solid mixed with solid, solid mixed with liquid, solid mixed with gas, right? And in the second type of solution, these are binary solutions which are generally called as liquid solutions, and here the solvent molecules are constant, that all the molecules are liquid, and liquid added to liquid, liquid added to solid, liquid added to gas, like this. By changing the solute molecules, the overall component, the solution goes on changes. So therefore in binary solution the second type is liquid solution, that is liquid added to liquid, liquid added to solid, and liquid added to gas, right? So here the liquid is the solvent molecule. Similarly, in case of binary solution, the third important type of solution is gaseous solution, right? So here gas is constant, that taken as the solvent, and for example here if I consider a beaker, and here there are the gaseous molecule. So one time I can add solid, one time I can add a liquid, one time I can add gaseous molecule, right? So therefore by keeping one of the component constant, we can change the solid molecules like solid, liquid, and gas. Similarly solid, liquid, gas in case of liquid solution. Similarly even in case of gaseous solution, by keeping gas molecules as a solvent molecules, that is a fixed solvent molecules, we can go on changing the solute molecules like solid, liquid, and gas, right? So like this there are 9 different binary solutions. These are 9 different binary solutions, and the main classification in binary solutions are 3. One is solid solution, second one is liquid solution, third one is gaseous solution. Therefore solid plus solid, solid plus liquid, solid plus gas. In case of liquid solution, liquid plus liquid, liquid plus solid, liquid plus gas. Similarly in gaseous solution, gas plus solid, gas plus liquid, and gas plus gas, right? So that is the explanation about the binary solutions, right? So we already know that solution means it is a mixture of solute and solvent, right? So where solute is the smallest quantity or the smaller quantity, and solvent is the larger quantity, and solute plus solvent will generally convert into solution. The main type of solutions are two: homogeneous and heterogeneous, where homogeneous means both the solutions, that is solute and solvent, both components mix each other. And in case of heterogeneous, what happens? So both components will not mix each other. These are immiscible liquids. That is, there is a line of demarcation. And further, if you go for the binary solutions, binary means there are two components, and these are of three types. One is solid solution, liquid solution, gaseous solution, right? So and overall there are 9 different types of solution, that is solid plus solid, solid plus liquid, solid plus gas, liquid plus liquid, liquid plus solid, liquid plus gas. Similarly, gas plus solid, gas plus liquid, and gas plus gas. Okay, further we'll study about the determination of concentration of the solution. Already we know what is solution, what is solute, and what is solvent also. But how to measure that solution, right? So at least you have to get some idea to measure. So whenever you are measuring in terms of liters or in terms of kgs, right? So like that, there might be some kind of a unit for the measurement. And here for the expression of concentration, concentration means any amount of the solute or solvent or the solution which is taken for the measurement, that is generally called as concentration. So that concentration can be expressed in different ways. That can be expressed in the different ways. So that will explain today, right? So here the first one is mass percentage, right? So which means, so the mass percentage is equal to, there is a formula, mass percentage is equal to mass of the component in the solution divided by total mass of the solution, right? So mass of the component in solution divided by total mass of the solution into 100. Whenever you multiply with 100, so you will get the mass percentage of the solution. For example, so if I take in a beaker, if I take 90 grams of water and 10 grams of sugar, the total will be 100 grams of solution, right? So 90 grams of water. So in a beaker, if I take a 90 grams of water, right? So this is 90 grams of water. So for this I will add, right? So 10 grams of sugar. 10 grams of sugar. So if I want to calculate what is the mass percentage of the solution, I can use the formula, that is mass of the component in a solution divided by total mass of the solution. So therefore that is equal to, so the mass component of the solution, the component of the solution is sugar solution, that is 10 divided by total mass of the solution is 100. Total mass of the solution is 100. Therefore 10 divided by 100 into 100, because we need this in percentage. So here I can cancel these two and the overall value will be 10%. The overall value will be 10%. Like this I can calculate the mass percentage in case of any given concentration. So generally mass percentage is helpful in calculation of grams or whenever you measure in terms of kg. And the second one is volume percentage. The volume percentage is similar to the mass percentage. Whenever you measure in terms of liquid solution, we'll call it as volume percentage. Whenever you measure in terms of solid component, we'll call it as a mass percentage. So here what happens in case of volume percentage, there is also one formula, volume of the component divided by total volume of the solution into 100. Volume of the component divided by total volume of the solution into 100, right? So similar to this, so here I have taken this water and added sugar. So this is a liquid solution. We can take in terms of volume percentage also. If you want to calculate the volume percentage, you can use the formula, volume of the component divided by total volume of the solution into 100. And the third important expression of concentration or expressing the concentration of the solution is mass by volume percentage. Third one is mass by volume percentage, right? So it is the mass of a solute dissolved in 100 ml of solution, right? So if you take any kind of mass, right? So desired value of mass, whatever the mass of the substance you take, if you dissolve that given concentration or taken concentration, so in 100 ml, only in 100 ml of the solution, that is generally called as mass by volume percentage. That is generally called as mass by volume percentage. Remember, so it can be asked for 1 mark. Define mass by volume percentage, which means it is the mass of solute dissolved in 100 ml of solution. The mass of solute dissolved in 100 ml of solution. Fourth one is parts per million. Generally we'll call it as ppm. That is generally called as, it is abbreviated as parts per million, right? The solute will be in trace quantity. Whenever the solute is taken at very less concentration or very trace quantity, we will use parts per million. Generally we will use parts per million, right? So whenever the solute is taken in a very micro level or very small level or very trace quantity, generally we will call it as parts per million. Therefore there is a formula for the calculation of parts per million is equal to number of parts of the component divided by total number of parts of all the component. Number of part of the component divided by total number of part of all the component into 10 raised to 6, because 10 raised to 6 is nothing but million. 10 raised to 6 is nothing but million. Therefore parts per million is equal to number of parts of component divided by total number of parts of all component into 10 raised to 6. By this we can calculate the parts per million. And the fifth one is mole fraction, right? So mole fraction is nothing but, mole fraction is equal to number of moles of component divided by total number of moles of all component, right? So this is very simple. Mole fraction is equal to number of moles of component divided by total number of moles of all components. So how much the total number of components are present in that molecule, by adding those, so in the denominator we can take that mole fraction is the number of moles of component divided by total number of moles of all components. This is important for your further study also. Always remember mole fraction. You have also studied in case of UC first year. Mole fraction is equal to number of moles of component divided by total number of moles of all component. Okay, here I can give the example for mole fraction, right? So mole fraction, that is a number, the desired component, that is divided by total number of component, right? So if you consider A and B are two components, right? So generally if you take A and B are two components, and in which Na is the number of atoms present in A and Nb is the number of atoms present in B, right? So therefore mole fraction for the first component A is equal to XA is equal to Na divided by Na plus Nb. If you want to calculate the mole fraction for xb, then we can take it as a nb divided by Na plus Nb, right? So I will do some rough work here for your understanding, right? So according to formula, mole fraction is equal to the component, that is the desired component divided by total number of component, right? So here we are going to define mole fraction, right? So if you consider there are two components, A and B are two components, and Na is the number of atoms in A and Nb is the number of atoms in B. Na is the number of atoms in A and Nb is the number of atoms in B, right? So here if you want to calculate the mole fraction for A component, right? So for A component, right? So for A component, so I can calculate the XA value, that is XA is equal to right? So the main component, the desired component or required component, that is Na divided by both, by adding both, that is Na plus Nb, right? So Na by adding Na plus Nb. So if you want to calculate the mole fraction for component, that is B component, right? So for the second component, or a mole fraction for B component, right? So you can calculate for that also. So that is xb is equal to, right? So Nb divided by Na plus Nb, like this, right? So this is the mole fraction of any kind of, or how much number of the components they give, go on adding in the denominator, right? For example, if there are three different A, B and C, if there are three different components, say Na is the number of atoms which are present in A, Nb is the number of atoms which are present in B, and Nc is the number of atoms which are present in C, right? So for A component, so X, right? So that is XA is equal to Na divided by Na plus Nb plus Nc, right? So you have to add all the three components in the denominator, that is divided by total number of component, right? Similarly, xb is equal to, right? So nb divided by, again same, Na plus Nb plus Nc. Similarly, xc is equal to, right? So Nc divided by Na plus Nb plus Nc, right? So like this you have to calculate the mole fraction. So therefore mole fraction is very important for your further study also. The same thing I have written here. So if there are more than 2 or 3 components, you can take the summation. Right? So summation means, so it is a continuous addition of the total number of components, that is xi. Generally you will written as xi is equal to ni divided, that is the ith term, ni divided by n1 plus n2 plus n3, right? So which means, so if it is continuously 1, 2, 3, 4 and continuously if it is up to ith term, you can take it as ni divided by n1 plus n2 plus n3 so on up to ni. So therefore you can make it as summation, that is summation of ni divided by summation. Summation means continuous addition of the given terms, that is n1 plus n2 plus n3 so on up to ni. So therefore I can write it as summation of ni, right? So like this you can calculate the mole fraction. Okay, the next important thing for the expression or expressing the concentration, that is molarity, right? So molarity, already we have studied in first PUC. Molarity is nothing but the number of moles of solute, dissolved in 1 liter of the solution, right? So whenever the number of moles of solute which are dissolved in 1 liter of solution, those are generally called as molarity. Therefore molarity is equal to moles of solute divided by volume of the solution in liters. Remember here we are talking about liters, right? So whenever the molecules are taken in terms of liters, so these are generally termed as molarity, right? So the amount of substance or the number of moles of solute which is dissolved in a liter of solution, so whenever we take liter, it is generally called as molarity. Therefore molarity is equal to moles of solute divided by volume of solution in the liters, And the seventh one is molality. So therefore molality is nothing but number of moles of solute dissolved in 1 kg. If we take in terms of 1 kg, we will call it as molality. If you take in terms of 1 liter, so generally we will call it as molarity. Understand? So it might be the 1 mark question for your annual examination. Most of the time it is repeated. Molarity also, right? So molality is equal to moles of solute divided by volume of the solution in liters. That is number of moles of solute divided by volume of solution in liters. But in case of molality, what happens? The number of moles of solute dissolved in 1 kg of solvent. If you divide with the help of 1 kg, or if you dissolve in 1 kg of solvent, right? So 1 liter and 1 kg are both are not same. There is a greater difference between 1 kg and 1 liter. Therefore, whenever you take the solvent molecules of 1 kg, it is generally called as molarity, that is L, right? L. And whenever you take the solvent molecule in terms of 1 liter, you will call it as molarity, that is R, right? So understand, don't get confused. Molarity means so moles of solid divided by volume of solution in liters. Molality means moles of solid divided by mass of solvent in kg, right? So these are the 7 important terms or 7 important ways for expressing the concentration of any kinds of solution, right? So once again, we'll see what are the important terms for the expression or expressing the concentration of solution, right? So in that, first one was mass percentage, second one was volume percentage, third one was mass by volume percentage, fourth one is parts per million, fifth one is mole fraction, and we also know how to calculate the mole fraction when there are more than 2 components also, and the summation also we have seen, and the fifth one is mole fraction, and the sixth one, right? So the sixth one is molarity, and the seventh one is molarity, right? So in these different ways, we can express the given concentration in the solutions. Okay, the next important concept in this chapter is solubility. So further we'll study about solubility. Solubility means it is a capacity of the solvent to dissolve, right? So for example, here I will do some rough work, right? So if you take a beaker, so I will say that this beaker consists of a liter of water, and here I will add 5 grams of sugar, right? So the solubility, right? So solubility is generally called as, it is a capacity. So it is the capacity of the solvent to dissolve, right? So the 1 liter molecules or 1 liter whatever, so that is the capacity of this 1 liter of water to dissolve this given component or to dissolve this added component is generally called as solubility. Solubility is nothing but a strength, right? Solubility is nothing but the capacity of the solvent to dissolve the added solute molecules, For example, so here if I take 2 different beakers, so this is the first beaker, this is the second beaker. In first beaker, I will take it as a water, right? So first beaker, I will take it as water, and in second beaker, I will take it as oil, right? So any kind of oil, right? So here, if I add 5 grams of sugar, same quantity of sugar for both the solvent molecules. So water has a greater ability, or water has the greater capacity to dissolve this added solute molecules, but the oil will not easily dissolve the added solute molecule, because so it is called as the capacity, right? So the capacity of the solvent molecules, right? So capacity of solvent molecules, so to dissolve the added solute molecules generally is called as solubility. So generally there are 2 types here, or 2 cases you will study here. So in that, solubility of solid in liquid, that is the first type. So if you take a container, and if I take 5 liters of water in that, and if I add 1 kg of sugar, so that is dissolving a solid in case of liquid. Here if you observe, solid is added to liquid, which means a liquid is the solvent molecule and solid is the solute molecule. So therefore, whenever you add solid to liquid, you will get 2 different cases, right? One is saturated solution, another one is unsaturated solution, right? So saturated solution means, so no further solute molecules can be dissolved at the same temperature, right? So if you take a container and if you put any kind of, for example, if I take this container, so in this container already I have taken a water, I will add 5 grams of sugar, it will dissolve. I will add plus 5 grams of sugar, it will be dissolved. Further, if I add 5 grams of sugar, that will also dissolve. If I add again another 5 grams of sugar, so it will not dissolve, because so the water or whatever the solvent which is taken, it has some capacity. Above its capacity, so it cannot take any kind of molecules or incoming the sugar molecules, or it cannot further dissolve. So that is known as saturated, which means which is already settled, which is already completed. Even if you add more amount of sugar for this, right? So even if you add more amount of sugar for this, so it does not dissolve. It does not dissolve any kind of sugar molecules or any kind of solute molecules. Therefore, at the same temperature, if you heat, what happens? Further, there may be a chance of addition or dissolving of that solute molecules. But if you won't change any temperature, which means at the same temperature, the solvent molecules does not have any further capacity to dissolve the added solute molecules, and this is generally called as a saturated solution. So therefore, saturated solution means no further solute molecules can be dissolved at same temperature. At same temperature, no further solute molecules can be dissolved. So that solution is called as saturated solutions. And second type is unsaturated solution. Unsaturated solution means the solute molecules can be dissolved at the same temperature, right? So if you further add, right? So here if I take 1 liter of water, if I add 5 grams of sugar, it will dissolve. And if I again further add any kind of 5 grams of sugar or any kind of salt, it will allow or it will dissolve the added molecules, right? So which means still it has not reached its capacity, or it has not overcome its capacity. Still we can add the components which can dissolve in that. That is called as unsaturated. That is opposite of saturated, right? So in saturated, what happens? The components which cannot be further dissolved in case of the solvent molecules at a same temperature, but in case of unsaturated solution, what happens? The solute molecules which can be further dissolved, in case of same temperature, without changing the temperature, and that is called as unsaturated solution. Okay, there is one more thing for your study, that is case 2, solubility of solid in liquid. Generally there are two types of solubilities. So first we have studied, that is solubility of a solid in liquid, and second one is solubility of gas in liquid, right? So here I can show the representation. If I take two component here, right? So these are two component, and here in both cases it is liquid, right? So here it is also liquid component. Assume that it is a water molecule. Here it is also liquid component, right? So assume this is also same, that is water molecule, H2O. So here if I add sugar, right? So that is sugar plus water. Sugar is a solid component, and if I add a hydrogen gas, right? So hydrogen is a gas. So which means these are two types. So this is case 1. In case 1, what we have studied? So that is solubility of solid in liquid. So that is solubility of solid in liquid. So here it is a case 1, that is solubility of solid in liquid. Solid in liquid, right? So here we are studying in case 2, right? So case 2, it is a solubility of gas in liquid, right? So case 2 explains about the solubility of gas in liquid, right? So further we'll study what is the major difference between solubility of solids in liquid and solubility of gas in liquid, right? So whatever we have studied today, so that is about the basic explanation about the solutions and the definition, what is a solution, as well as we have studied two types of important types of solution, that is homogeneous and heterogeneous. Along with that, we have studied the binary solution, that is solid solutions, liquid solutions, as well as gaseous solutions. Along with that, we have also studied the expressing the concentration of solutions. The different concentration of solutions also we have explained. So there are 7 different types. One is mass percentage, volume percentage, mass by volume percentage, parts per million, and mole fraction. Along with that, molarity, as well as molality also we have seen. And further thing we have studied, that is solubility. Solubility is nothing but the capacity of a solvent to dissolve. It is nothing but the capacity of a solvent to dissolve. Capacity of the solvent to dissolve. The added component is generally called as solubility. In solubility, we have seen the two cases. One is solubility of a solid in liquid. Second one is solubility of solid in gaseous molecules, right? So some of the rough works I have done. So try to make notes, your own notes, and also I will give notes in our WhatsApp also, right? So that's all about today's classes, and tomorrow in the next classes we'll continue with the Henry's law as well as the applications of Henry's law. Along with that, there are some explanations related to the different colligative properties, and we'll see that one, and we will try to derive some of the derivations, like elevation in boiling point, depression in freezing point, similarly osmotic pressure, and what are the further applications or uses that can be studied in the next concept. Thank you. We'll continue in the next class.